I guess I just don't understand how this helps with version control.
Containerization. Scene 1, take 1.
Have you ever spent time on some code that works great on your machine, but not on someone else's? Or maybe you've been forced to test it in production because you have no good method for quickly deploying applications. Or maybe you're just looking for a more modern development strategy. Containers can help with all of that, but they can't hold your sandwich. Containers as a concept are nothing new, but in recent years, a push for open industry standards around container formats and runtimes under the Open Container Initiative has allowed this technology to flourish in the context of industrial automation. But if it can't hold my sandwich, then what exactly is a container? A container is a software application you run born from a specific container image. The container image bundles an application along with its dependencies, configuration files, and libraries into a single package that you can easily move from one system to another. The container runtime coordinates launching a container in isolation such that it sees only its own files and processes independent from other applications or containers running on the host system. Instead of the overhead of separating workloads through emulation of an entire system as with virtual machines, containers leverage host features like namespace and C groups to isolate resources while executing under a shared system. Put simply, containers only contain what you need to run your application. That's it. By including only the necessities, containers are lightweight, making deployment much quicker. And because the container is self-contained, it will run more uniformly across any machine, be it on-prem or a cloud-based VM. So, what do you need to start using containers? For this example, let's run an Ignition container with Docker. If you're unfamiliar with Ignition, it is the unlimited enterprise industrial integration platform for SCADA, HMI, MES, IIoT, and more. You should check it out. To set up a containerized architecture, you'll need a few pieces of hardware and software. First, you need an IT infrastructure that includes physical compute resources, something like a server, desktop, or laptop. Then you will need a container runtime or container engine, such as Docker Runtime Engine. This becomes the conduit for containers to share a host operating system with other containers. If you're running on Linux, you'll need to download and install the container runtime and Docker Compose individually. Docker Desktop, which is available for Windows and Mac OS, includes both the Docker Engine container runtime as well as supporting tools like Docker Compose, which we'll talk about some more in a minute. With Docker Desktop, the underlying Linux VM is managed for you along with the integration of the tools for the host OS that you seamlessly use to connect to them. Next, you need the container image. An image is essentially the schematic for the container, defining the dependencies, configurations, environment variables, and everything else required to run the application. While a container image itself is immutable, you can use it as the foundation to create a new image separate from the original. That's called a derived image. This new container image allows you to add your own additional files, environment variables, and configurations to better align with your specific needs. The final piece is a software application that runs in the container. In this case, that's Ignition. If you used Ignition before, you might be wondering, how can a software with a perpetual license that is delegated to a specific server work with something as inherently ephemeral as a container? That is a good and extremely specifically worded question. You can use the leased license, which is an 8-character license, versus the typical 6-character one. These types of licenses need to check in with an activation service frequently to remain valid, but you can reuse the license with an activation token, making it perfect for containers since you can spin it up and then spin it down whenever you need. Okay, so we understand the why and the what, but now we get to the how. How can you, the container-curious developer, leverage containers to supercharge your development? Instead of segregating workload across multiple virtual machines, containers allow you to easily model complex architectures with multiple gateways, databases, communication brokers, and a variety of different services. Docker Compose, which we mentioned earlier, allows you to define multiple different containers, whether it be Ignition, a database, a web server, and define them all in a text format that is easily creatable, copyable, and editable. Containers make it easier to organize multiple projects for when you're balancing different clients or systems. And within each of those projects, containerization makes it much easier to spin up staging environments, create digital twins, as well as give each developer their own fully integrated test environment. To get a little more complex, containerization lets you create multiple environments, each for dev, test, and production. Say you have 2 gateways and a database. Containers allow you to have a development copy, a test copy, and a production copy. That gives each developer a method to spin up the application locally and work through their own process before merging it with the rest of the dev, test, production path. Containers can also help people who don't use containers, or maybe don't even know what a container is, until you show them this video, of course. Here's the scenario. All of your developers are working together on a project, but your project manager doesn't need to dig into the code every time they want to review a development branch. You can spin that container up on a server, simply give the project manager a URL, and they can review whatever they need, all while the other engineers are working in their own local environments. Testing in general becomes easier when you start spinning up and breaking down containers, allowing you to turn Ignition into an extremely efficient ad hoc tool throughout the development, testing, and production lifecycle. Containerization is a very deep topic. If you'd like to go more in depth with step-by-step instructions for how to use and configure Ignition containers, check out the links to Inductive University and the Ignition user manual in the description below. Like and subscribe. Well, now I want that sandwich.